Hello everyone, I Goinda Gahine, lecturer in mining department at Chhattisgarh Swami Vivekananda Technical University, Bhilai. Today I will discuss lecture number 29, supports. So, first I will discuss the material employed for support. The following material are commonly used for the mine supports entirely as such or in combination. These are timber, usually saw, and in comes area leak is used for props, bar, chocks or cock and legging. Iron and steel in the form of bars, props, arcs, corrugated sheets and roof bolts. Bricks or building stone in masonry walls or arching. Reinforced concrete or precast concrete blocks as roadway lining, roadway reaping, dirt band and shale as back walls, sands, earth, boiler ash, washery, reject, mill tailings, slag from blast, furnace for smelting iron and crushed stone as packing of goaf and filling or whites. Research into storing lightweight material for underground supports has shows that the most promising one is glass fiber reinforced plastics. These have not been introduced in our mines as yet. Tests in Russia have shown the CBAM framed support for development roads weight 1/7 or 1/8 as much as precast reinforced concrete and 1/3 as much as timber frame. CBAM is a soint glass fiber product. Precast concrete assembles as support have been seldom used in our mines. They have the serious disadvantage of great weight and difficult in handling. The type of support to be built up depends on the importance of the place to be supported. The period for support is cost and availability. So, timber is most commonly used material for support in a mine as it is cheap and easily available. Dry and seasoned sal, sakwa, props and bars are used in some parts of Maharashtra and Pench Valley coalfield where teak growth is plentiful. Saw props are available in length up to 9 meter. The size of saw props used for roof support are generally as follow. Height of gallery 1.2 meter to 1.8 meter, 1.8 meter to 2.4 meter or 3 meter and above. Diameter of props at thick end 100 mm to 125 mm, 150 mm to 175 mm, 175 mm to 225 mm. A timber prop is sometimes called stool in metal mines. Timber used in the mine is subjected to two main diseases during use: dry root, wet root. The diseased timber is soft and weak in strength, moreover is warped and is subjected to attacked by fungus leading to decay. Decayed timber forming part of mine support has to be replaced frequently. The unseasoned timber, also called green, is prone to dry or wet root. Timber treated with chemical in special kilns is normally not used in mine, and the common method is to dry it in the open for a long period. This causes the sap in the wood to evaporate to a great extent. In the colliery store yard, the timber is too stacked that it is kept clear of the ground, free from dampness, and permits air circulation to individual members. Turnover of the timber at intervals helps in maintaining the conditions which are not conducive to attack by dry or wet root. Look at the figure. In the figure, you can see the all type of timber props and wedge patterns. Next is setting props. A timber props were erected in a mine to support the roof should yield slightly under the roof weight. The timber prop is strongest when the load acts parallel to its length. A prop as such is almost unyielding, but a certain yield is obtained by taping it at the foot or top, or providing a lid on the top of the prop as a compressible cushion between the roof and the end of the prop. In flat seam, the prop is erected vertical, and in inclined seam, axis of the prop should be normal to the dip of the seam. The prop then offer the maximum resistance to the roof. A prop which is so set that its axis is between the vertical and the normal to the seam is known as underset prop. Erection of underset props is not common, as it is not possible for the timber man to judge whether it is underset or not. Prop should be set on solid floor and not on loose packing or debris, except in case of emergency. If the prop has to be set on loose rock, loose coal or sandpack, it should be placed on a flat base piece not less than 5 centimeters thick, 25 centimeters wide and 0.9 meter long. Such prop on loose coal or rock should however be removed as early as possible and replaced by prop erected on solid floor after cleaning up loose rock or coal. If the floor is soft, the base piece of or foot lid mentioned here is to prevent prop penetration in the floor. In our coal mines, the floor is generally hard. A timber prop expected to support a roof area of about 0.4 meter to 1 meter all around. The props are erected on hard floor in seams of varying thickness as follows. First, roof height up to 2.5 meter. Prop is held upright in the place where it is to be erected, a lid placed on top of it, not nailed, and a wedge is hammered between the lid and the prop to be tightened the lid against the roof and the floor. Generally, for this thickness, the lid and wedge are not used as two separate pieces, but the lid is to made slightly tapering along the length, that is serve the purpose of wedge also. If there is any cracks or slip which needs support, the lid should be placed across the cracks or slip. A lid serves to distribute the resistance of the prop over a slightly wider area than its cross section. To prevent penetration of the props into the roof and to indicate the load on the prop, it also helps easy withdrawal of the props. Wedges are used to tighten the prop against the roof and floor. The lids and wedges should be at least of the same width as the diameter of the prop, of a minimum thickness of 80 mm and a length of 0.5 meter. The position of the bottom end of the prop on the floor corresponding to the place in the roof to be supported is marked by a plumb bob suspended by a bamboo. The prop is held upright by 2 or 3 timbers helpers The timbersman standing on a high stool or a ladder places the lead and a wedge is hammered in a position. The above method required a stool or a ladder to be carried from place to place for probe erection. The more convenient method is a lead is attached to the probe by nails or a hole is made nearly 25 mm deep in the floor, where the bottom end of the probe is to remain after erection. The probe laid on the floor with the bottom end in the holes is made upright the holes, preventing the props from slipping. The props is held in position by timber helpers, and one timber helper levers up its bottom ends by a crowbar, bringing the lead in contact with the roof. A wedge is then hammered between the probe and the floor to tighten the lead against the roof. Next, roof height above 4.5 meter. The method is used for roof heights beyond 4.5 meter also. The lead is fixed to the probe by nail. The probe is raised upright in the position of erection by helpers with the help of a fork of the type or by a rope tied to the probe with a special knot which releases the rope when pulled. The probe is tightened up by the timberman by hammering a wedge at the bottom in the same manner at stand. In inclined seam steeper than 1 in 5, it is used to fit the foot of the props into a stamp hole in the floor. Tapered props. Tapered props are not much used in Indian mines. About 200 to 500 mm length, one end of the tapered and the other end is provided with a lead. Tapered end should be in contact with the hard surface. These props are used where the floor is hard and the roof soft. With increasing roof pressure, the taper end burns and provides yielding. Next, timber bars. Bars act as beams. A timber bar is placed in the holes of minimum depth of 500 mm in the side of a coal pillars. The sides are strong. If the sides are weak, the bar is placed on vertical props. If the bar is circular in cross section, the top end of the prop should be hollowed out to fit the contour of the bar. Alternately, the bar may be flattened at each end so that the end can rest on flat ends of the props. The bar should always be tight against the roof and should offer the maximum area of contact against it. The side of the bar towards the roof is chopped flat for this purpose. Flat wooden legging are also used if the roof is uneven. Next is safari support. The conventional method of supporting galleries in coal mines is by means of wooden crossbar. For fixing this crossbar, holes are to be made in the coal pillars manually by crowbars. This is timber consumption and the whole operation of fixing one crossbar by this method taken about 2 to 2.5 hours. Therefore, the supporting lag much behind the working phase for quick setting of the crossbar. The manual cutting of hole in the coal pillars is eliminated by drilling holes with the usual coal drill, and a support known as safari support is installed to support the roof. This support consists of a pair of clamps of mild steel on which a crossbar is placed to support the roof. Each clamp consists of an angle iron frame to which semicircular brackets is welded as a seat for the wooden crossbar, and in the angle iron two holes 35 mm dia and 175 mm apart are provided for two rods of 32 mm dia and 700 mm long. The two ms rod of each clamps are inserted into the hole drilled in the coal pillar. The crossbar is placed in position over the two brackets and tightened against the roof with wooden wedge. The complete operation of setting the support is complete in 15 to 20 minutes for each crossbar. The clamps can be easily recovered and used again for several times. The support extends the effect of blasting and the freshly exposed roof is supported in a short time after exposure. One of its application is to support the split gallery in deepering area in thick seam and extract the floor coal, heightening the gallery up to 5 meter. During extraction of stokes, wooden chocks are provided in the split gallery and later on the clamps are recovered completely for reuse. Safari support require strong coal pillars in a thin seam. The effective height of the gallery is reduced, which is a disadvantage where coal loaded baskets have to be carried or head for tub loading. You can see on the figure the exact figure of safari support, in which the number of bars are shown and the lagging portions, also wedges and the roof. Next is side support. Wooden lagging are placed tight between vertical props and pillar where the side are weak and need support. Sometimes the timber set of prop and bar has to resist pressure from side, which tends to crush into the roadway. Nothing is useful in such cases. The prop should be set at an angle of 40 degree to 20 degree of the vertical and the feet wall sunk into the floor. An alternative method of resisting side pressure is to sink the props well into the floor and to reinforce the timber set by an addition bar to stature, which may be nailed to the props. As this reduces effective height of roadway, its use may not be advisable in roadway of less than 2 meter height used by basket loaders. Next, support by wooden caulk, chalk or chalk mat. A chalk, caulk or chalk mat is a combination of sleepers above one another, is a crisscross manner. It support a much larger stress than a prop and is used in places where the roof is bad over a wide area and need a substantial supports. Caulk are also erected where main roadway have to pass through area having coal pillar of inadequate size. The term chalk mat is generally used in metal mines. Caulk are required under the regulation at gouge edge at junction of split and galleries in tippling area, in board and pillar working and at break of the at the gouge on long wall faces. Only rectangular sleepers or alternately sleepers having their two opposite sides chopped flat should be used. The minimum length of sleeper for a caulk to support roof at a height up to 3 meter may be 1.2 meter, but for a roof height in excess of 3 meter it may be 1.5 meter. The sleeper should have a minimum cross section of 100 mm into 100 mm. The caulk should not be normally erected on loose floor or debris, but on natural floor or on secure foundation. The floor area over which the caulk is to be erected may be excavated for a depth of 25 to 50 mm and should be made nearly flat in seam of mild inclination. Member of the caulk are placed at right angle over the member immediately below in pairs. The caulk is tightened against the roof by hammering wedge. It is at convenient height. When we dowel the caulk, withdrawal of such wedge loosen the caulk and withdrawal of the sleepers becomes easy. The caulk should be tight against the roof and this may be tested by hammering for looseness at the uppermost sleeper. In some cases, a caulk is erected in between 4 corner props. Such corner props are generally not necessary except where the roof is very bad and at gouge edges of gallery and at junction of galleries, and if the floor is sleeper is 1 in 5 where corner props are erected. One sleeper of the caulk is always placed outside the props. Withdrawal of the member helps dismelting the caulk. Support of roadway. Where the roof of a roadway is bad over some distance, bar resting in holes of coal pillars and tightened against the roof by wooden legging may be erected at interval of 2 to 3 meter. If the coal pillar are not strong enough or the road is rough, a fault zone, the wooden bars are supported or timber props. This is common practice where the roof pressure is likely to be heavy. Bars may be supported on timber chocks. A method of supporting a wide junction by caulk and bars. No props should be erected at such a place where they are likely to be dislodged by moving or derailed and runway tops. The bars may sometimes be placed on brick wall constructed on solid foundation of coal floor with 150 mm layer of concrete at the base. Next is systematic timbering. Systematic timbering is the terms used for erecting support in such a manner that the distance between support are according to a specified pattern as laid down by the manager and approved by the Directorate of Mine Safety. Systematic timber is essential in a districts of board and pillar working where splitting of pillar or depiling is going on. On every long wall working phase, in every forking in a disturbed or crushed ground means fault zone, and at other place where the DGMS may so direct. The type of support to be erected, whether caulk, props or bar, are also specified in the order governing systematic timbering. In every cases of systematic timbering, it is essential that additional support shall be erected as and when necessary. Manager has to hand over copies of systematic timbering rules to all the supervising officials and has to post such copies at conspicuous places in the mine. Withdrawal of support. When props, bar or caulk have to be withdrawal is to prohibited by law. To withdrawal them by hammering. Suitable safety props withdrawals like the Sylvester prop withdrawer has to be used. It is an advantage to fix the chain C on the prop PG in such a manner before withdrawal that when the chain is pulled and is getting tightened, the props receives and slides twice, an action which loosen the props in its position. Look at the figure. This is the general procedure of withdrawal of supports. In the deplering areas, a long chain is often required to place of the chain C. To avoid such long length, a flexible wire core with steel cores like 15 mm diameter coal cutting machine haulage rope having capels at both the ends may be used in conjunction with the use 6-meter long chain. Where the roof is high, a suitable anchor prop may not always be available for operation of prop withdrawal. In such case, a piece of rail is fixed in a half-meter deep hole in the floor. It serves the purpose of anchor props. Alternately, a strong bar fixed in the coal pillars may be used to serve the object. Care should be taken to see that the anchor prop or other prop which provides safety to the timberman operating the props withdrawer should not be dislodged by the props under withdrawal when it is released. Next is iron and steel for mine supports. Iron and steel are used in mine in the form of rigid and yielding props, beams and girder reinforcement in concrete, corrugated sheet and roof floor bolts. Disused rail of 36 lbs section or heavier section are sometimes used. Steel is incombustible and its use greatly reduces fire risk in mines. Steel props used in the mine are rigid props and yielding props. An ordinary S section steel girder of suitable length with the wave cut away and flange turned over at one or both ends in the common type of a rigid prop. If the props bucket in use, it can be straightened by hydraulic press. Situated at the pit bottom, another type of steel props consists of a steel pipes containing a well fittings umber course through measure length and extending 25 to 40 mm beyond the steel pipes at either end. The timber core yield to some extent to the roof pressure and gives indicate of roof weight. Advantage of rigid steel props over timber are: first, row of steel props offer uniform resistance if properly set. Second, a steel prop has a greater ultimate strength than timber. Third, recovery of steel props and frequency of its reuse is greater. If bucket, it can be straightened and reused, but a timber props once broken cannot be reused except as legging. Next, a steel props does not deteriorate to the extent timber does. Timber decay in a number of ways, particularly by dry roots. Next, they are incombustible. Disadvantage of steel joints props are: large props are difficult to tighten against the roof and may therefore be knocked out. A large manpower is required for handling them. Wooden props gives warning of heavy weighting which steel props do not. A simple joint prop cannot be used in seam of varying thickness. Cutting at a long prop and turning its flange cannot be done at the site of erection. Next is roof bolting. The terms of roof bolting is applied to the practice of drilling vertical hole in the roof and fixing steel bolt into them in such a manner that the bolts grips the strata and support the immediate roof. The bolted roof strata behave as one thick beams capable of supporting not only their own weight, but the weight of the strata above. The general scheme of support by roof bolts: first is slot and wedge bolt. It consists of AMS rod 25 mm diameter, nearly 1.3 meter long, split at one end and for near 160 mm, and threaded at the other end for about 125 mm. Into the slot is fitted at wedge 150 mm long. To install the bolt in position, a vertical hole nearly 125 mm less than the length of the bolt is drilled, and the bolt having the wedge fitted at the split end is inserted into the hole and hammered in position. The split end having the wedge somewhat widens in the holes and grips the rocks. A bearing plate of mild steel 150 mm into 150 mm is placed on the bolt and a nut is tightened. The better the grips, the sounder in the installation. This type of bolt is popular as it can be easily made in the colliery workshop, is cheap in the first cost, and can be installed in holes drilled by the usual coal drill. It cannot be recovered. Principle of action of roof bolt. There are three theories put forward to explain the action of roof bolt. First, beam theory, second, keystone theory, third is suspension theory. The beam theory is widely accepted. According to this theory, the roof bolt assists in joining together the rock beds through which the bolts passes. The joint bed form a sort of thick beams which supports the weight of the strata above. For example, if a single wooden plank, say 6 mm thick and 6 meter long, is supported at its two ends, it will bend considerably in the middle under its own weight and may even breaks. But if several of such planks are clamped or bolted together, the composite beam so formed will be much stronger than the single planks and will support not only its own weight, but also some heavy weight over it. Thank you.